Hello everyone, welcome to our presentation on manufacturing process technology. Today, our group will present our digital portfolio focusing on welding as a manufacturing process. Let's begin. Manufacturing is the process of converting raw materials into finished products using machines, tools, labor, and different manufacturing techniques. It is an essential part of modern industry because it improves product quality, increases production efficiency, and reduces manufacturing costs. Manufacturing plays a major role in industries such as automotive, electronics, medical equipment, construction, and consumer products. One of the most widely used manufacturing processes is welding. Welding is a fabrication process used to permanently join two or more materials, especially metals, by applying heat to create fusion between the workpieces. In some cases, a filler material is also added to increase the strength of the welded joint. After cooling, the joint becomes strong, durable, and permanent. Because of its reliability, welding is commonly used in the construction of buildings, bridges, pipelines, vehicles, and ships. Now, let's look at the different types of welding. The first type is shielded metal arc welding, or SMA, which is also known as stick welding. This process uses a flux-coated electrode to create an electric arc between the electrode and the workpiece. The intense heat melts the metal and forms a strong welded joint. The advantages of SMA include its low equipment cost, portability, and ability to weld rusty or dirty metals. However, it has a slower welding speed, requires frequent electrode replacement, produces slag that must be removed, and requires experienced welders to achieve high quality. The second type is gas metal arc welding, commonly known as MIG welding. MIG welding uses a continuously fed wire electrode together with a shielding gas to protect the molten weld from contamination. This process offers high welding speed, is easy to learn, produces clean welds, and is suitable for automated and robotic manufacturing. Its disadvantages include higher equipment costs, the need for shielding gas, poor performance in windy outdoor environments, and the requirement for clean metal surfaces before welding. The third type is gas tungsten arc welding, also known as TIG welding. TIG welding uses a non-consumable tungsten electrode together with an inert shielding gas to produce high-quality welds. It provides excellent precision, creates clean welds without slag, and is ideal for thin materials such as stainless steel and aluminium. However, TIG welding has a slower welding speed, higher operating costs, and requires highly skilled welders.
Welcome to this welding process walkthrough. We'll start by planning the design, choosing materials, and setting clear requirements. From there, the materials are prepared and cleaned so they're ready for fit-up and assembly. Once the pieces are aligned, the pre-weld checks confirm everything meets the needed standards before welding begins. After welding, the work cools naturally, followed by cleaning to remove any residue. Inspection and testing ensure the weld is strong and safe. Finishing smooths the final look before all details are reviewed and recorded. With everything approved, the welding process is officially complete. Next, let's discuss the industrial applications of welding. In the automotive industry, welding is used to manufacture vehicle frames, body structures, chassis components, and exhaust systems. In the energy industry, welding is essential for constructing oil and gas pipelines, nuclear power plants, and wind turbine towers. It is also widely used in the production of pressure vessels and pipelines to ensure leak-free and durable joints under high pressure. In heavy machinery manufacturing, welding is used to build equipment such as excavators, bulldozers, cranes, and other industrial machines. Safety is always the highest priority during welding operations. Welders should wear proper personal protective equipment, including welding helmets, gloves, protective clothing, and safety boots. Good ventilation is necessary to prevent inhalation of harmful welding fumes. All welding equipment and cables should be inspected before use to ensure they are in good condition. Hot metal should always be handled carefully after welding, and a fire extinguisher should be available nearby. Maintaining a clean and organized workplace also helps prevent accidents. In conclusion, welding is one of the most important manufacturing processes because it produces strong and permanent joints for a wide range of engineering applications. Each welding method has its own strengths and is suitable for different materials and production requirements. For example, MIG welding is ideal for high-speed production, while TIG welding is preferred for precision work and high-quality finishes. To improve manufacturing performance, companies should select the most appropriate welding process, use automation where possible, preheat thick materials when necessary, store welding electrodes correctly, and inspect critical welds using non-destructive testing methods. By following these practices, manufacturers can improve product quality, increase productivity, and ensure safety. Thank you for listening. That concludes our presentation. We appreciate your attention, and we are happy to answer any questions you may have.